All right, so now we're going to do part 2. And with part 1, just one more thing. I'll give you one more example here. If we have, let's say we have a square. And let's say I tell you that so square, let's say the perimeter is 36. What is the length of a diagonal? Okay, I'll put a question mark there. Well, if the perimeter is 36, all 4 sides are equal, we can divide this by 4, and we get 9, 9, 9, 9. Now, if we want the diagonal, let's draw the diagonal. And in a square, when you draw a diagonal, you create not just a right triangle, but a 45, 45, 90 right triangle. Well, 45, 45, 90, the ratio is 1 to 1 to the square root of 2. Leg, leg, hypotenuse. Now this time we know the legs. Here's x. We know the legs are 9. How do we go from a leg to a hypotenuse? We multiply by square root 2. So our answer is 9 square root 2. Okay? You could do Pythagorean theorem. You could do 9 squared plus 9 squared equals x squared, but this is much faster. So that is for a 45, 45, 90. The other special triangle comes from an equilateral. Now, you look at an equilateral and you say, wait a minute, that's not a right triangle. All 3 angles are 60. That is correct, but if I draw an altitude, okay, here's the altitude. What it does, an altitude creates a 90-degree angle with the side that it intersects. Now we created a right triangle, but we know that this angle is 60 and this is 30 right here. Let's say that all the sides were 4, 4, 4, and 4. And we want to find, I'll call this x and y. When you have an equilateral or an isosceles triangle, when you drop that altitude, it's going to bisect the bottom length here. So it's going to bisect the 4, which means that's 2 and that's 2. So right away, we got x. Okay, that's good. Now, to find the altitude, let's do Pythagorean theorem. A squared plus b squared equals c squared. So y squared plus 2 squared equals 4 squared. So plus 4 is 16. We have to subtract the 4. Y squared is 12. And when we square root that, 4 is a perfect square factor of 12. 4 times 3. The square root of 4 is 2. So we get y equals 2 square root 3. That is your altitude. So we get this length is 2, this leg is 2, and then this leg is 2 square root 3. Now what happens, these are not the same because it's not isosceles. So on the side here, when I draw a 30, 60, 90 triangle, that's what this is called, 30, 60, 90. Here's the hypotenuse. I call this the short leg. That's opposite the 30, that's the smallest side, and then the longer leg opposite 60, I call the long leg. Now, if we look at the ratio, so the short leg in this example was 2, so we had 2, I'll write it over here. And then the long leg was 2 square root 3, and then the hypotenuse was 4. Now, each of these could be divided by 2 if we reduce, and what we get is 1. We get 1 square root 3, and we get 2. That is the ratio for a 30, 60, 90. So we have 45, 45, 90, and now we have 30, 60, 90. That's the second kind of special triangle, special right triangle. So I'm going to write it here, 30, 60, 90, 1 to the square root of 3 to 2. Now this is the short leg, I'll put SH. Here's the long leg, and this is the hypotenuse. This is the second relationship. Now, this one's a little bit more in-depth because you have 3 different values. We don't have equal length for the legs. But let me give you some examples. Again, you can do these very quickly if you know the ratio. So let's say we know that the short leg is 4. Actually, let's make it different. Let's make it 5. Okay, short leg, here's x and here's y. Well, the hypotenuse is always twice the short leg. Because if you think back, if it's equilateral, which is where this triangle would come from, if I extend that, this would also be 5. So the whole thing would be 10. And since all 3 sides are equal, that's 10. So to get to the hypotenuse, the short leg to the hypotenuse, we go times 2. 5 times 2 is 10. There's y. Now to get to the long leg, to go from the short to the long leg, what we'll do is we'll multiply by square root 3. So if this is 5, then x is 5 square root 3. That's it. Okay, let's say that the short leg is, we'll say 8. Short leg to hypotenuse, we go times 2. So 8 times 2 is 16. Short leg to long leg, we multiply by the square root of 3. Here's 8. That's 8 square root 3. You're done. No Pythagorean theorem necessary. Okay, use the shortcuts. All right, what if I give you something else? What if I tell you the long leg is, let's say, 14 square root 3? So now, the long leg is always opposite 60 degrees. So if we start at the long leg, we always want to go back to the short leg first. If we don't have this, if they give you long leg or hypotenuse, the first move is to go back. To go from square root 3 back to 1, we divide by square root 3. So I would take 14 root 3, divide by root 3, but anything divided by itself is 1, so I can cross those out, and what we get is 14. How do we go from the short leg to the hypotenuse? Well, we multiply by 2. 14 times 2 is 28, and you're done. Okay, what if it looks like this? Let's say this is 8 root 3. Nope, sorry, we just did that example. Let's say it's 10 root 3. There's x and y. Okay, long leg is 10 square root 3. How do we go back? We divide by square root 3. If we do that, what we're left with is 10. How do we go from short leg to hypotenuse? We multiply by 2, and we get 20. That's it. What if they give you the hypotenuse? What if we start and we say this is 18? Here's x, here's y. Now the first move, if we have the hypotenuse, we want to go back to the short leg. Well, to go from 2 back to 1, what we'll do is divide by 2. Okay, I know I'm writing kind of small there. Divide by 2, and 18 divided by 2 is 9. How do we go from the short leg to the long leg? We multiply by square root 3, and that's 9 square root 3. And that's it. Okay, so depending on what you're given, let's say I tell you we have an equilateral triangle. Let's say the perimeter is 26. What's the length of the altitude? Let's make the perimeter 27, actually. Make it a little bit nicer. Perimeter is 27. Okay, so we're going to drop an altitude right here. That's what we're trying to find. Now, if the perimeter is 27, that's all 3 sides. So to get one side, because they're all the same, divide by 3, and we get 9, 9, 9. When we drop this altitude, it's going to bisect the angle here. There's 30. Here's 60. So here's the hypotenuse. Here's the short leg. To go from hypotenuse back to short leg, we divide by 2. Now, 9 divided by 2 is not perfect. I can just write 9 over 2 as a fraction. To go from the short leg to the long leg, all we do is we multiply by the square root of 3. So what we would end up getting is 9 root 3 over 2. That's it. Okay, what if I told you that the altitude of an equilateral triangle, is, we'll say, 12 square root 3. What is the, let's say, one side of the triangle? Okay, so what is one side of the triangle? Okay, so let's draw an equilateral. Let's draw the altitude. So that's 12 square root 3. When we draw that altitude, we create a 30, 60, 90. There's the 30, there's the 60. Okay, now the short leg, to go from the long leg back to the short leg, we divide by root 3. So divide by root 3, there's 12, and then multiply by 2, that's 24. So 24 is the side of the triangle. If you wanted the perimeter, you would do 24 times 3, which is 72. Okay, now there's one more case with a 30, 60, 90. I'll take one more sheet of paper here. Let me rewrite what we've got, 30, 60, 90. Now I know I'm talking through this kind of fast. This does take practice. This is very quick, but you do need to practice how you move from one piece to another. So you do have to put in some time so that you're not getting confused. All right, the one case where you have to be careful, what if we knew that the long leg, let's say it was 9. Here's x, here's y. So we're starting with the long leg. To go back to the short leg, you have to divide by square root 3. Now the problem is, I don't have a square root 3 on top that's going to cancel this. So, and I can't do 9 divided by 3 because the 9 is not under a radical sign. So what we did, what we're going to do is the same as what we did with the 45, 45, 90. If you have a square root in the bottom of a fraction, we are going to multiply both the top and the bottom by the same thing, this time square root 3. Now, in the top numerator, we get 9 square root 3. In the denominator, the square root of 3 times itself is just 3. So what happens is we cancel out the square root here. Now, when you look at what's left over, you can't touch the square root number. However, the other two numbers, 9 and 3, we can reduce. That would be 3 over 1. And the answer is 3 square root 3. So the only time where you really need to do work is if this long leg does not have a square root of 3 attached to it. Okay, what if, let's say this was 15. Here's x, here's y. So again, that's opposite 60, that's your long leg. Okay, so I divide by square root 3. Well, I can't do that. I can't leave it like that, so I have to multiply by a fancy form of 1. We get 15 square root 3 over 3. We can reduce. 15 and 3 is 5, so the answer is 5 square root 3. That is our x. Now to find the y value, we'll go back and do it for the last example. To find the y value, that's the hypotenuse. To go from short leg to hypotenuse, we do times 2. 5 square root 3 times 2. You're allowed to multiply the outside numbers, okay, not the square root 3 part, but just 5 and 2, and you get 10 square root 3. We are doubling this, multiplying by 2. In the last example, 3 square root 3, the short leg, times 2 would be 6 square root 3. And that is the end of the notes.